Our second focus lesson is going to be pretty quick. One of the things it's going to ask us to do is use mental math to find a product. Now, I don't really expect for you to do this in your head, but I do expect for you to kind of understand what we are doing with these numbers to make it easier to work with. For example, if you were trying to do 299 times 3 in your head, it would probably be pretty difficult, but if you learn how to use the distributive property to your advantage, it actually can help out. So if you look at this example in problem 4, it says deli sandwich costs $4.95 each. What is the total cost of 8 sandwiches? Let's look at the problem here. 8 times $4.95, again, is pretty hard to do in your head. But notice what they did with the $4.95. They found a simple number like 5, which is pretty close to $5, and they subtracted 5 cents because $5 minus 5 cents is $4.95. Notice that when you distribute it, 8 times 5 is easy to see as 40. 8 times 5 cents is easy to see as 40 cents, which means that you take $40 minus 40 cents, which makes $39.60. So using this, there is an addition way and a subtraction way. What we are going to look at right now is the subtraction way. So you have $2.99 times 3, and all I want you to do on this is practice looking at this and saying, okay, $2.99 is pretty close to 300, and that would be 300 minus 1. And we're going to multiply that by whatever is on the outside, which is 3. And again, noticing this is 3 times 300, which is easy enough to do. That's 900 minus 3, which of course makes 897. With no long multiplication needed, no calculator needed, you can kind of figure that stuff out, because again, it's not too bad to do. Same thing on 47. You have 6.15 times 4. Again, that's a lot of numbers to deal with, so let's see if we can do this easier. As 4. This here, 6.15, is pretty close to 6, and what we'll do is add 0.15 to that 6, because 6 plus 0.15 is 6.15. When you take 4 times 6, you get 24. And 15, if you think about a clock, 15 minutes is from here to here. 4 of those sections, 1, 2, 3, 4, is 60 minutes. So 0.15 times 4 should be 0.60, which means in the end you end up with 24.6 or 24.60, depending on how you wanted to do that. So again, that is your mental math work that you can do on that. The second thing we're going to do is do what we call combining like terms. You've already kind of been combining like terms, but this is just making it official now. Let's look at problem number 5 and see exactly what they're doing here. In problem A, it just says simplify the expression. You have 8x squared and 2x squared, which, if you look at the answer, 8x squared and 2x squared turns into 8 plus 2 times x squared. I guess they did the reverse distributive property, which we'll learn is factoring, and then 8 plus 2 is 10x squared. In other words, I have 8x squareds here plus another 2x squareds here, which gives me 10x squareds altogether. Same thing on this one. On B, they have 5x minus 3x plus 6y plus 4, and what they did was they rewrote it using the commutative property by putting 5x together with negative 3x, since both of these have an x on them. Looks like they left the 6y where it was, and they put the negative 3 and the positive 4 because those are both constants. Remember, they don't have a variable on them, so they're both constants. They then said 5 and negative 3 makes 2. 6y, of course, came down, and negative 3 plus 4 is positive 1, and they wrote that down as your final answer there. So let's see how this works here in our work. Number 55 gives us 5t minus 7t. And the easiest way to do this is to ignore the t's, not understanding that both of these have t's, which means we can put them together because they're like terms, and just ignore the t and do the math. 5 minus 7, if you do that, it is negative 2 with a t on it, and that's all you're going to need to do. 59 is negative 4y squared plus 9y squared. Again, once you see that both of these have y squared, it means that they are both like terms. You then ignore the y squares and say negative 4 plus 9. The 9 has more, so it wins. You subtract and you end up with 5 y squared as your answer there when you combine them. And then 63 simply gives us a couple things to think about. Like terms have to be exact. In other words, even though this has a H, that has two H's, and that has an H, all of these are not like terms. And so what I'm going to do is put or underline the like terms here. 7H, because it just has one H, is like terms with 4H. So -7, -4 are the like terms here. And what we're going to do here is ignore the H's and look at the negatives. You have -7, -4. Remember that the signs are the same, so you add them up. And since 7 is bigger, it makes -11. And since we're talking about H's here, the term just comes down, or the title for the term just comes down. 3H squared has no like term, so we just bring it down the way it is. And -3 has no like term, so we just bring it down the way it is. Now if you're putting this in standard form, they usually want the highest power first, which means that we will put 3H squared in front, -11H second because it's negative, and then -3. Now do you have to do the standard form? Not yet, but eventually you will, so you might as well go ahead and practice it. If you did this on a test, it would be okay. What I need you to do now, though, is to go ahead and write these down and spend some time working on these for the rest of the day.